Thank you, Nidhi. Hello, everyone. My name is Vijay Kanchanahalli. I'm a product manager in Azure Specialized Compute team focused on accelerated virtual machines for targeted for remote visualization, graphics, gaming, and a little bit of AI inference. And with me, I also have Sherry from our team. Sherry, would you like to introduce yourself?
Hello everyone, my name is Sherry Wang. I'm the product manager in the specialized compute team in Azure. So I focus on the product line for GPU accelerated virtual machines for AI workloads. I'll introduce our portfolio after VJ. Thank you.
Thanks, Sherry. So in this session, we are going to talk about Azure's infrastructure strategy for workloads that are related to remote visualization, graphics, gaming, and also on the compute side, accelerated compute, which is AI machine learning or AI inference or AI training. So starting with, we'll start with the overview of the different kinds of virtual machines that we have in Azure that support accelerators, some form of accelerators. At a high level, we have three family of virtual machines: NV, NC, and ND. They're all powered by different accelerators. Some use NVIDIA GPUs and some use AMD GPUs. And then they're all optimized for different workloads. So for example, the NV line of virtual machines in Azure is optimized for applications that graphics applications like, for example, virtual desktops or VDI in the cloud, uh, remote visualization, and workstations. NC and ND line of virtual machines, they're focused more on the compute side with accelerators. So NC is targeted towards light to medium compute, for example, rendering or machine learning inference. And ND is optimized more towards really high-end training. Sherry will talk more about our NC and ND line of virtual machines, and I will focus on our NV line of virtual machines. In the visualization market, this pyramid is a representation of the different user profiles. It's not an it's a high level representation of how we look at the market as a whole. For example, there are at the bottom of the pyramid you see the regular designers or desktop as a service users. These are users, a typical laptop, on-prem laptop users. If you see, every laptop today comes with an integrated graphics chip. I am actually running this call from my Surface Pro laptop, which has a graphics chip in it. Although I'm not using a graphics-heavy application, but my productivity applications like Outlook or Teams, through which I'm running this, doing this presentation today, uh, those applications all get benefited from the integrated graphics chip I have on my Surface Pro laptop. So, and as these users move to the cloud, they also expect similar experience where from an on-prem laptop migrating to a virtual PC in the cloud, you would love to have graphics acceleration for applications that can make use of it. And this is the user profile where you don't really require a full GPU. You require because you're not really running a graphics heavy application, right? And then when you look at the next layer in the pyramid, these are users, typical workstation users, who run applications that actually require a GPU. Right? Without a GPU, most of these applications will not even perform, or they will not perform at a level that, as a user, you expect them to. And at the really high end is the users with lots of resource requirements. These could be users that require multiple GPUs, they require high-end GPUs, or they require lots of memory. For example, we have had customers who require more than a TB of RAM in a virtual machine, which is not a typical use case. But there are, we have enterprise users where a small set of users will require really, really high-end virtual machines. and because they run workflows or applications that require uh, a heavy compute and resource requirements. So that's at a very high level, the three different user profiles. It's not an 100% accurate representation, but it is a high level summary of the way we look at users in the remote visualization segment. So what do we have in Azure that meets these requirements, and what do we have coming? Right, that's what we want to talk about in this session. Quickly talking about what we have today in generally available in a lot of the regions in Azure. We have the NVV3, which is based on NVIDIA M60 GPU, and we have the NVV4, which is based on the AMD MI25 GPU, and these are our existing SKUs. I'll talk a little bit about NVV4 before I jump into what's coming later in 2022. NVV4 with AMD MI25 is the first instance in any cloud with partition GPUs. If you are familiar with the NVIDIA on-prem technologies, vGPU is what NVIDIA uses on-prem, but we are using SRIOV based implementation. We are actually partitioning the GPUs. Taking a full physical GPU and slicing it all the way down to 1/8 of a GPU and offering it to virtual machines. And as a user, you have the flexibility to scale up from really small GPU VM, and based on your workload requirements, you can scale up or down. So we launched NVV4 a couple of years ago, and NVV3 has been around for quite some time. So in 2022, this year, we are actually introducing two new virtual machine series as a follow-up to both of our existing NVV3 and NVV4. The first virtual machine series that is coming out for preview, in fact, next week, is the NV810V5. This is a follow-up to our NVV3. It's based on the NVIDIA Ampere A10 GPU, which is a GPU from the latest Ampere line of products from NVIDIA. And this is also the virtual machine series where we are introducing GPU partitioning on NVIDIA. So previously, we had GPU partitioning only on AMD GPUs. And a lot of customers provided us feedback that this is something that they would love to see on an NVIDIA GPU on Azure as well. So with NV810V5, we're introducing GPU partitioning on NVIDIA. And this is, I'll talk more about the details, but at a high level, the three key callouts here is, GPU partitioning. We have up to 880 gigs of virtual VM memory, which is double than what we have today on NVV3. And we have also doubled the front-end network, Ethernet network throughput to up to 80 gig for the full-size VM. And last, we had a lot of feedback from customers on, the CPU performance compared to on-prem and in the cloud, because a lot of the applications that our customers use are optimized for single-threaded performance. And one of the key feedback has been, can Azure give us a virtual machine with a really high frequency or a CPU? So, and we are addressing that in NV8 and NV5 while introducing the latest AMD Milan CPU with really high frequency. I'll talk about the details in a minute. And later on in the year, second half of this calendar year 2022, we are working on an AMD version of NVV5, which is going to be a follow-up to NVV4. And this is going to be based on the AMD V620 GPU. Again, this will have GPU partitioning similar to NVV4, up to 80 gigabit of front-end networking, and a high-frequency Milan CPU. So these are the two new SKUs that are coming out this year. And as you can see in the chart here, the way we are positioning these two virtual machines is that they complement each other, and we're trying to cover the entire pyramid, right? All the way from if you are a DAS user with really low VM resource requirements, all the way up to the really high-end use cases with lots of GPU and system memory. Now, going deep into the details of the NVV5, as I mentioned earlier, this queue is previewing next week. It's starting next week. And you can actually sign up for preview. The link is on the slide here. And we are officially open for preview, and we are accepting signups from users. and the table below talks about the different sizes of virtual machines with the GPU partitioning. So we are starting with, on the low end, a 6-core 55 gigs VM memory and 1/6 of a GPU partitioning. This is it equates to about 4 gigs of GPU frame buffer or VRAM, and then you scale up from there, and you can go to a virtual machine with 1/3 of a GPU, which is roughly 8 gigs of frame buffer, and then half an A10, which is 12 gigs, and then one or more A10s, right, with 24 gigs of frame buffer in each of the GPUs. So at the high end, you have two A10 GPUs with 880 gigs of memory and the full 80 gigabit of front-end networking. I talked about the high-frequency CPU. So in this platform, we have the AMD Milan CPU with a base frequency of 3.4 gigahertz, which is quite high, higher than what we have on our NVV3s and NVV4s today, and an all-core turbo of 4 gigahertz, which we expect that the applications that are optimized for single-thread performance will get a lot of benefit with this platform. We are excited to announce the preview next week, and we're looking forward to more customers like you signing up. And tentatively, general availability of this platform is, we're looking at, towards the end of the second quarter, sometime in May or June. The final GA date we will decide based on how the preview progresses. But I'm excited to announce the preview and looking forward to seeing a lot of customers like you participate in the preview. Now I'll hand off to Sherry to talk about our roadmap on the NC and the ND series.
Yeah, thank you, Vijay. And right now, I would like to introduce our AI virtual machine. And Azure has been offering the high-quality VM to accelerate AI workloads through the past few years. And we offer a wide range of VM to cover different type of workloads. From the slides you can see, we have a light compute VM to cover the lower cost of hosting AI service when you need them, where you need them. Where a light compute oriented with a light compute oriented GPU instance. And we have mid-range VMs offers versatile throughput-oriented options for batch inferencing, analytics, demand business workload, and for the mid-range AI training. We also has high ambitious VMs to let customer with their really scale up their models without slow down, featuring the industry's fastest GPU networking. During the past few years, we have seen customers roll out multi-regions inferencing-based service that need to hit new price point to be able to appeal wide use base. We also see customers try to pushing the envelope of what natural language AI can do. And for them, training the billion parameter plus model is routine. The gamma between a real-time inferencing requirement where you need a lot of small GPUs and a wide footprint to the effective use of GPU supercomputer to train the models. And we're proud to have a portfolio that has kept pace with this requirement. You are able to develop a deployment GPU-based virtual machine from 1 T4 all the way to thousands of 800s. So first, I would like to introduce the NDM 800V4 virtual machine. It's our high-end distributed AI training platform. It's powered by NVIDIA Ampere SXM GPU instance. We have 8 NVIDIA 880 gigabyte GPU interconnect with the NVLink and NVSwitch. We offer 20 gigabit InfiniBand HDR link per GPU with full NICO support and GPU direct RDMA. So with this offering, you can scale up to the large size of model like GTP3 and to get better performance from it. And this virtual machine, this NDM800V4 SKU also achieved the top 10 ranking in top 500 supercompute from the worldwide. We have partnered with OpenAI and other key customers to try to offer the latest, greatest virtual machine to the market. Right now, Azure is the only one who can offer the 80 gig memory cloud solution on the 800 GPU platform. So in the upcoming month, we are offering another mid-range AI training GPU to preview it as our next generation NC series. The name is NC800V4, and it's powered by NVIDIA 800 PCIe GPUs. We offer from 1 to 4 per VM, and it has the latest PCIe 4.0 solution, and also has the NVLink bridge between the paired GPUs. This virtual machine series is ideal for real-world applied AI workload, including GPU accelerated analytics, databases, batch inferencing, and some heavy pre and post processing. Also, you can use it for the autonomous driving, reinforcement learning, oil and gas reservoir simulation, video processing, and AI ML web services, and more. We have a sign up link here, and you can sign up for preview, and we will try to see where we can help you get a taste of our next generation mid-range AI training virtual machines. So as I mentioned, we have 3 product lines, and we also have a new product coming out later this year to fulfill the future inferencing and light compute platform. It's NC800V4. As more and more customers are board on Azure, they often seek validation. Specifically, customers want to know which applications will run on Azure HPC and AI platform with the best cost performance. And to fulfill these needs, we crafted this NC810V4 SKU. It's powered by NVIDIA 810 GPUs with support for GPU partitioning. You can choose from half of the 810, full 810, and 2 810s. The spec down below lists out all the options we offered within this GPU, within this virtual machine. And it supports latest generation architect delivered double the performance over our original T4 GPU offering. Also, it supports full array of Azure storage options and faster networkings with accelerated networking feature for up to 80 gigabytes. So beyond all the technical spec we list down on here, Azure GPU accelerated virtual machine for AI offering, we add more values from software tier to help you better operate, manage, and run your workload on our hardware more easier. I would like to head over to our software platform lead Rob to introduce that offerings.